So hello again guys. I'll be doing right now is that I'll continue my presentation. I'll present now the Boolean algebra and the simplification rules. So as you may see, we'll go through the simplification formulas, the Morgan rules, the operators precedence, and some applications. Then I'll go into the canonical form and the standard form for the mean terms, max terms, or the SOP and POS. And the last part will be to present the Carnot map or the K-map. So at the beginning, some few definitions concerning the mathematical tools and the basic definitions concerning the Boolean algebra, associative law, the commutative law, the identities, the inverse, and the distributive law. In fact, I'll not go through these because they are more related to math courses. I'm sure that you have taken all these in math. They are just here in this presentation as a summary for you to refresh your memory. So, who was the first one to create the Boolean algebra? It's George Boole. It was about mid-19th century, but it was with Shannon, who effectively published this study and worked. Excuse me, and worked in advanced ways to show some real applications. Here is the photo of. So here is some terminology that we'll be using all along this course. Mainly the literal or the variable. The product term, which is a dot term, it is represented by the AND operator, and the sum terms, which is the plus, which is represented by the OR operator. In fact, the OR here you have to take into consideration that when doing the OR, 1 plus 1 will be equal to 1. It's not 10. However, for the plus, 1 plus 1 is equal to 10. But just this difference. So here are the main rules, simplification rules. For the addition, when adding x plus 0 will have x. When adding x plus 1, it's always 1. X plus x is x, and x plus x prime or x bar is equal to 1. As for the multiplication, multiplying by 1 will give x, but multiplying by 0 will give 0. X times x is x, and x times x prime is 0. So the double negation also is equal to the variable, so x double prime is equal to x. The commutative product plus or multiplication, x plus y equals y plus x, same for the multiplication. And going through the associative, distributive laws, and ending by the De Morgan rules, which is x plus y prime, all x plus y is prime, it's equal to x prime times y prime, and x times y all is prime equal to x prime plus y prime. And at the end, the absorption rule, x plus xy will be equal to x into 1 plus y, which will be equal to x, and x into x plus y will be equal also to x. So one way to justify this calculation is by using the truth table. In fact, for example, I have included here only the truth table for the De Morgan theorem. We have two variables, x and y. So what I have proposed is to see what is equivalent, the value equivalent to x plus y bar, all bar, and the value of x bar times y bar, and we can see that they are equal. Same goes to theorem 5b, which is xy all bar equal to x bar plus y bar. So this is one of the ways to make sure that our simplification is correct. So what you are supposed now to do is these two formulas. I want you to do the simplification of these two equations, f1 and f2, to plot the truss tables, to draw the truss tables, and to do the circuits. In fact, we have to draw the initial circuit and the simplified circuit, and here also we'll compare between the number of logic gates used in each case, in order to see if the simplification was valid or it was interesting to do the simplification or not. So now I'll continue with the canonic or standard form, which is, it can be mentioned as being the mean terms, max terms, or the SOP/POS, sum of products and product of sums. So for the mean terms and the max terms, the mean term is a standard product. It is represented by the AND product. So in fact, mean terms are, for example, xy is a mean term, xy prime is also another mean term. Same goes to x prime y and x prime y prime. So it is, let's say, equivalent to the sum of products. So it's xy plus xy prime plus xy prime, x prime y plus x prime y prime. As for the max term, which is the OR term, it is linked more to the product of sums. So here in this case, it is x plus y, x prime plus y, x plus y prime, and x prime plus y prime. Oh, excuse me. See that they constitute all the 8 elements. So to sum up for this part, the canonic form is any Boolean expression. It can be represented by a mean term or max term. Note the most important thing is that to know they are complements. So in any function, the term which is not part of the mean term is part of the max term, and vice versa. For the zeros, they are max terms. For the ones, they are mean terms. Also, if we want to go into the standard forms, the standard presentation, in this case, we mean that in any part of the equation, all the variables must appear. So for example, if we go to the function f, which is equal to a plus b c prime, in this case we have 3 different variables, which are a, b, and c. So for the first term, which is a, we need to add b and c. Back to the simplification techniques. In fact, if we can remember, b plus b bar will be equal to 1. Same goes to c plus c bar. So we multiply a by b plus b bar plus c plus c bar. So it's like multiplying a by 1 times 1. So it will be a. Same goes to the second term. So we multiply b c bar by a plus a bar. So it will be a plus a bar into b bar c. So, and you will develop the whole equation. If we have a redundant element, we have to remove it, and thus we'll obtain this mean term product, or the sum of products. And here is another example. So for the mean terms, in order not to confuse, it is small letters of m, or it can be a sum, the sigma of elements. For the max term, it is a big value of m, capital M, along with the product. Here is another example. So I'm asking you to prepare the third one, the xy plus x prime z as product of max terms. So what we can do is to prepare them first as product of mean terms, putting them in the truss table, and the parts who have a 0 value for f will be the max terms. Here are other examples Also for min terms and max terms, and as you can see the sum and the product. So for example for f we have taken 1, 4, 5, 6 and 7. So the remaining parts, which are 0, 2 and 3, will be for the max term for the product. And here is the last example that you must resolve to show the POS, the SOP, and using the trust table. So the next session, the next part of the lecture will go through the K-map simplification, and will finish by showing some simple circuit serialization using NAND and NOR gates. Thank you.